Welcome to a new edition of the Heat Treat Podcast starting 2023. We have a great guest today. We're going to be talking about ultra large gears and very deep carburizing. We got with us Mark Podo, president and owner of MedLab, a commercial heat treat close to Philadelphia. First of all, how's it going, Mark? Great to meet you. And just before starting the podcast, you were telling me amazing things about this ultra large gear heat treating that I just would like to share. But first of all, can you just give us a little background of Mark Podo of MedLab, that it's maybe one of the oldest heat treat companies in North America, founded in 1928, and a little of your technical background. I mean, because you have been in the industry for more than 50 years, if you don't mind.
Oh, I'd be happy to. In fact, one of the things that I have to be very cautious of is that sometimes I talk too long, and I like to tell my story, so I have to be careful not to tell.
We got time. We got time.
Not to talk for a long time, but I have to tell you. So I grew up in Brooklyn, New York, and I was interested in metallurgy from a very early age. I went to a high school called Brooklyn Technical High School. In New York City, there are very specialized high schools that you can attend, and Brooklyn Tech was like a pre-engineering high school. And when I went there, the very first day of school, I was taking a class called Industrial Processes, and the teacher in the beginning of class said, "Does anybody know how to type?" And I knew how to use a typewriter. And he said, "See me after class." And I saw him after class, and I said, "How can I help you?" And he said, I'm rewriting the textbook for the class. And what I'm doing is I'm writing my manuscript longhand, and I need somebody to type it up on mimeograph stencils. A mimeograph was a precursor to the Xerox copy machine. And so I said, "I'll be happy to do that." He said, "Okay, I'll give you 25 cents a page for every one you type up." So I said, "Okay." So I started typing his manuscript, and we started typing. The first chapter was glass, and then we typed plastic, and we typed wood, and then we got into metals. And as I typed this stuff up, I said, "This is pretty interesting stuff." And I became fascinated with metals. And I was one of the few guys in this engineering high school that actually stuck with the program. And I graduated and then went on to go to college and studied metallurgical engineering and got my bachelor's and master's and stayed as an engineer. Most of the other guys became teachers, or they went to medical school, or dentists, or lawyers, or what have you. But I stayed with it and stayed in engineering. And I graduated, got a degree, and then I went to work for Pratt & Whitney Aircraft, and I started out in failure analysis. And I discovered that I really didn't so much want to be an engineer as much as a salesman. I enjoyed sales. So I gravitated out of engineering and moved more and more over to sales. Ended up working in powder metal, worked on nickel-based superalloys, and then moved more and more into heat treating. I took a position with ABAR, which was a leader in the field of vacuum furnaces. And then ABAR was acquired by Ibsen Industries, and I became the national sales manager. I had 6 sales offices across the country, where I had 6 sales managers that reported to me, and we were selling vacuum furnaces, and I had field service engineers who reported to me. It was really a very exciting time. This was the 1980s, when vacuum furnace sales were very strong, and it was just a very, very good position, a very, very good time in the industry. And after that time, took another couple of positions, and then finally MedLab became available, and I acquired the company with a partner. His name was Jim Conybeare. Jim was technical director for ABAR and Ibsen, and Jim and I bought the company. And we became heat treaters. And at the time, the company was a very fascinating company. It was founded in 1928. It specialized in the heat treating of large components, primarily gears, bearings, large structures. Jim and I bought the company and we expanded it. We grew it. At the time, there were 18 employees. Today, we've got about 40 people. Jim retired about 5 or 6 years ago, and then I became the sole owner of the company. And we've been very successful. There's always been a challenge. You know, people say, how is the company doing? How are things going for you? And what I like to say is, I say, listen, you know, we survived 9/11. We survived the recession. We survived Katrina. We're in the middle of COVID. We're emerging from COVID. We're here. We're doing okay. You know, we're doing fine.
So you have a very strong technical background, also in sales and a variety of processes. And I encourage the audience to go and go to the webpage, Medlab Heat Treating. Look it on Google. The pictures are just amazing of very, very large gears and pinions being heat treating. So that's pretty amazing. So you having a very strong technical background, when you encounter MedLab, were you already heat treating these huge gears and huge pinions, or that was a spin-off that you made?
No, you know what? In all honesty, when we acquired the company was really in decline. It had some problems, and you know, it took two young guys, because at the time we were pretty young. It took two young guys to energize this old company.
Which year was this when you acquired it? Sorry, didn't get it.
We bought the company in 1998.
1998.
Yeah.
1998.
And the large furnaces were here. They actually had installed a large furnace in the 1980s, because they had landed a contract from a company making transmissions for submarines, for the Seawolf submarine. And these were large gears. They probably weighed 20,000 pounds. And they were the main propulsion drive systems for the Seawolf submarine. The gears were about, I want to say, maybe 12 feet diameter by 12 feet tall. They weighed 20,000 pounds, and they were being nitrided. And the company that was making them received a contract from the government to put a furnace in and to do the nitriding on these gears. And it was a very robust contract. I think they must have heat treated about maybe 20 or 24 of these large gears for submarines, nitriding them.
Well, and I just want to say to the people viewing this podcast that when I came here and I thought we're going to be talking about large gears, no, these are ultra large gears. Mark was sharing with me the applications, both submarines, steel mills, and he was sharing that they're heat treating 45,000 pound gears that stays on a furnace for 1 week to get the necessary case dip. So give us an introduction of ultra large gears. I mean, because there's people here that they heat treat stuff like the guys in California, very, very tiny stuff, but for the aerospace industry, the furnaces are very, 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 very small. But when it comes to heat treat these huge parts, I mean, what's unique about it? How the handling, I mean, I assume there will be no destructive testing because it's only one part.
Well,
so,
exactly.
So what's unique and how do you heat treat these ultra large parts? Can you give us an introduction, please?
So the very first thing we did back in the late 90s and the early 2000s, when we got a hold of this company, is that nobody, to our knowledge, was doing parts this large, and we were approached by several companies who were looking to manufacture large gears for applications in the steel industry, for gears to drive rolling mills and those type of parts. And we had the furnaces, but at the time, the furnaces weren't capable of going to those high temperatures for carburizing. There are a lot of gear companies out there that can make large gears, but they can't carburize them. And they asked if we would modify our equipment so that we could do that type of work. And we said, yes, we would. So we insulated our largest furnace. Our largest furnace is 15 feet in diameter, works on 15 feet in diameter by 12 feet tall. And we did that. And we went ahead and solicited that type of business. So what you've got to do is you've got to make sure that when you are heat treating these large gears, you shim them properly to minimize the distortion. You put them in the furnace, make sure that they sit in the furnace completely flat, so there's no chance for them to pick up some extraneous distortion where they can possibly bend, distort, go out around, because these are the things that can cause them to just get a lot of distortion. My God, you take a 45,000 pound gear, put it in the furnace for a week and quench it and temper it and take it out and measure it. And if it's distorted and it's scrap, we're talking about a lot of money.
Oh, yeah.
And
we're talking about pit furnaces here, mainly?
we're talking about, I'm sorry?
Pit furnaces.
Pit furnace, yeah.
Pit furnaces.
Yeah,
These big gears are treated on pit furnaces.
Yeah, this large furnace that we're talking about sits in a pit. The pit is roughly 18 feet deep, and everything everything's done at ground level. But I mean, it sits in a very deep pit. The quench tank that's associated with that furnace is also about the same size. It will hold about 30,000 gallons of oil. So it's and plus we've got an oil cooler, so we can extend the capacity for quenching these large 40,000 pound gears.
I bet it's a large oil cooler.
Yes, it's a large oil cooler. Yeah, as we were talking before we went on and started recording, we've got 3 large gears in the shop right now. One gear is roughly about 12 feet in diameter by about 4 feet tall. It's a solid gear. It weighs about 45,000 pounds. It's being carburized to a case depth, an effective case depth of 250 thousandths. And it's going to be in the furnace for roughly a week before we take it out and quench it. It's a very dramatic quench when you pull out a gear that tall. We have 2 10-ton hoists that sit over that furnace. And it's really quite something to maneuver these.
Oh yeah.
To maneuver these gears. We have a roughly 125,000 square foot facility. The aisleways themselves are very large because you have to get these large gears and these large components down the aisleway. So there's a lot of space. When we get a large component like this, it takes a special kind of a truck driver. You have to pay special consideration on how you transport these parts. So we have one company that we do work for, and we know when we're going to get this special kind of a gear, we call them up. We say, hey, make sure you send this special truck driver who comes all the time, because he's a guy that can back the truck right down in our plant, right down the aisleway, and maneuver it so in between the furnace and the wall, so they can get the gear out with the hoist and get it in the furnace. When we do a gear like that, there's a fair amount of masking that takes place. We work fairly closely with the manufacturers of stop-off paint, because most of the stop-off paints that are manufactured for the gears are only good for about 125 or 150 thousandths case depth. So we will carburize these gears to about 125, 150 thousandths case depth. We will stop the carburizing halfway through the cycle, cool the gear down, take it out, repaint it, and then put it back in and finish the cycle.
Okay, the paint will wear out or something?
The paint sometimes doesn't last the whole cycle, and my gosh, if you have to take a gear like that out and you get a paint failure, you're looking at hours and hours of.
So you cool down the furnace, people get in, or the part goes out?
No, we actually take the gear back out.
Okay.
Lift it out of the furnace, put it back out. When we do the painting, we have some special fixtures that we take the gear and set it up on these fixtures, so it's up in the air, suspended, so the guys can get underneath it and paint underneath as well as on top.
Okay, and then it goes back. Is there?
And it
like
goes back in the furnace.
Is there like a measurement over there to see how much case that we have gained?
We do. Yeah.
Yeah. How do we do that? I mean, you have to take a case hardness tester to the part, or do you have a sample How will you do it?
So when we're carburizing to such a deep case depth, we do put sacrificial pieces in the furnace.
Okay.
It's interesting. We actually call the samples Pac-Man samples because that's what they look like. They're round samples with a gear tooth actually cut into them.
Okay.
So it looks like a Pac-Man.
Yeah.
And that's actually it's probably about 6 inches or 8 inches in diameter with a big notch in it.
And you take that and you take the Pac-Man texture to the lab and you see how much.
We take it in the lab. We cut it up.
Doing. Okay.
Cut it up and take a piece out and polish it and etch it and we do a micro hardness traverse and measure the case depth.
Okay.
So when we carburize something for about a week, every couple of days we take a sacrificial sample. We actually have a porthole in the furnace where we can pull a sample out without interrupting the cycle. We take that sample out, we quench it, so we get it hard, and then we cut it up and polish it and take a micro hardness traverse. So we check the progress of the carburizing, and then there is something called the K factor. The K factor is a measurement of the progress of the carburizing, and by adjusting temperature and adjusting carbon flows, we can change the rate of carburizing.
And for this type of steels, I mean, for this type of parts, which type of steels are we talking about?
So there are several steels that the gears are made from for carburizing. The original steels which are used for manufacture of the gears are 4320 or 8620. These are the traditional steels that are used for fabrication of these gears. The newest steels, and 9310 is also a very popular steel. The newest steels that are coming in more in vogue are 17 or 18 chrome nickel moly steels, which are more highly alloyed and just a more robust steel for the applications.
So then we got the gear over there for a week. We cool it down. We might repaint it. We can pre-measure, the Pac-Man tester, and we lit it up. And when do we know that it's finally carburized? We quench it. Correct. Right. The handling is gonna be, amazing to see. I believe it's a very, very cautious and has to be very well managed in order to quench. Is that very severe? We see flames out. Is that very impressive to see? Or
it is very impressive because what happens when you quench these gears, or when you quench anything? I mean, it's no different from quenching a handful of small parts. Is that the first thing that happens is the part enters the oil, and you get flames. I mean, the part. So carburizing is done in the temperature range of about 1750 degrees Fahrenheit. And then what you do in our case, we almost always cool the part back to room temperature. We cool the part back to room temperature. We open the furnace cover and we take out the test piece. The test piece gets rehardened and we check the test piece to make sure that it's got enough case on it. We'll take the test piece, we take it back up to 1550 degrees Fahrenheit. We quench it in oil, and then we go take it in the lab, we cut it up, and we do a micro hardness traverse to make sure that we met the appropriate case depth requirement. If we've met the case depth requirement, then we authorize the production people to go ahead and heat the gear back up. It takes about, for a 40,000 pound gear, takes about a day and a half to heat it back up to temperature. And then you soak the gear for 1 hour per inch of thickness. That rule of thumb applies across the board.
Mm-hmm.
At the end of that 1 hour per inch of thickness, we go ahead and we quench it. So what that means is we open the cover and we take the gear out, move it over to the quench tank and quench it in the oil. So as the gear enters the oil, you get flames. The gear at 1550 Fahrenheit hits the oil and the oil ignites. When the gear goes underneath the oil, the flames are extinguished. There's nothing left to feed the flames. We let the oil sit. We let the gear sit in the oil for about 3 or 4 hours until the temperature equalizes, which is about 250 degrees Fahrenheit.
I gotta ask, what's the standard oil temperature when you're doing that? Is that hot oil?
So the oil temperature is pretty well ambient.
Ambient, okay.
Yeah, it's pretty well ambient. I would say it's depending upon the conditions. It's in the range of about 125 degrees Fahrenheit.
Okay.
And it will heat up to about maybe 200. I mean, it's a lot of oil we have, so it'll heat up to about 200 degrees Fahrenheit. When the oil equalizes, the gear sits in the oil for about 4 hours or so, and then we'll take it out. We'll wash the excess oil off, and then we'll temper it.
Is this the same temper for? Is this a different tempering furnace, or we use the same furnace?
No, we use the same furnace.
The same furnace, okay.
Yeah.
And the tempering time and range.
Tempering is done at about 325 degrees Fahrenheit, and again, it's about 1 hour per inch of thickness.
Okay.
Yeah.
Okay.
And in many cases, we're double tempering these gears.
And how will you wash all that oil? You will drain it. You will lift the part, and the oil will drain to the.
We'll lift the parts.
Yep,
we lift the parts, and we allow the oil to drain.
To drain, okay.
Yeah, we allow the oil to drain. Yeah, and when once the tempering is done, we're done. We call the truck. We load the gear on the truck. We write a nice big invoice.
Oh yeah, I bet.
We wish it well, keep our fingers crossed, and hope that the distortion isn't too bad, and we ship it down the road.
Okay. Which type of on automotive we talk about CQI9, on airspace we talk about NADCAP. Is there a specific regulation for this type of ultra large gears?
I'm sorry, I didn't hear that question.
Is there like a type of I don't know if you're familiar with CQI9 or NADCAP for quality control of heat treat for special process?
Yes.
Those applications, do they run on some standard, some norm?
The standard for the carburizing of these large gears is no different than the standards for carburizing anything else. I mean, they're basically the same. The quality control requirements are all the same. I might add, and I'm not embarrassed to say this, but we are not ISO, and we are not NADCAP. We work in accordance with ISO, and I have to tell you that despite the fact that we are not ISO, which means that we haven't had the survey done, we're probably more ISO than some companies that have actually had the survey done.
I bet. I see ISO as a standard, right? But if some companies are not required to have the certification by its customers, right? Yeah. Which is your case, I believe. But if you apply those good practices and you have your own quality system, it's as good or maybe as better as any other company, because there's a bunch of companies that they're required to have the system and they just cheat, right? So I'm with you. I'm with you. I respect that.
Yeah, we incorporated, and again, I'm glad to say this. We incorporated Blue Streak. I think everybody knows what Blue Streak. We incorporated Blue Streak about 4 or 5 years ago, and I'm glad we did, because it's great software, and it really is a good roadmap in terms of how to do things, and we're quite skilled at using it, and our quality people are very comfortable with it, and as I say, we're really quite good at what we do. I like to joke, and I say, our people creep around all day. They maybe don't work as fast as some other people do, but when it comes to one of these large gears and the guys coming together, it's like watching a ballet. The guys they know what they're doing. It takes to quench one of these gears takes about 6 guys. The way we fixture the gears. All of these gears have lightning holes. There are like 4 or 6 holes through the gears. And we actually run the fixturing to lift these gears up through those holes so that there's a grid underneath the gear. There is a 3 or 4 foot long rod with a hook on top that a hook from the hoist goes through to that hook, and the guys actually have to take a poker and line that thing up and get it to go into that hole. And it's just, as I say, it's like watching a ballet, to watch the guys move things around, and it's just I'm really quite proud of the job that the guys do. It really takes a lot of skill.
If you don't mind, let's talk about distortion. I mean, because distortion is always a big deal for every
Yes.
heat treater. And when we talk about standard gears for automotive, let's say, or for trucking, they're racked on a fixture which is designed and meant to run high volume of parts like that, and they start playing with temperatures. They start playing with agitation, with oils. But in this case, and most of the times, it's trial and error, right? Because
Yes.
they're doing on high volume. On the MedLab case, I mean, you do not have that. I will say you cannot do trial and error because it's only one part, especially for quenching, right? Because the part is distorted, I'm assuming the part has to be scrapped, right?
Yes.
Or there might be I don't know, wanted to ask you, there's a lot of remaining material, so it can be machined back. What could you share with us about that? Distortion.
Well, I mean, one of the things that you really need to pay attention to is to make sure that your grids and any of the other hardware that is associated with the handling of the parts are flat and are just in top shape. I mean, it is not unusual for us to take our grids and have them sent out and have them ground flat and parallel. That has to be done. In the case of a gear with a web, it's especially critical where the hub and the rim are maintained at the same level. So you have to work with the manufacturer of the gear to make sure that they're in tune with what your requirements are to minimize distortion. So, I mean, we've had cases where we'll get the design of a gear, and there could be something on there that we just don't like, where we think that it will lead to distortion, and we'll just talk to the engineers and say, listen, we can't have that. How about we just redesign this and we work together and see if we can't come up with something that makes more sense. And all the time we work together, and
Sure.
You've got to have a partner who's on board with what you need and what they need. And I think they understand that, we're working towards a common goal.
So they will set the spec and the drawing of the part with the, case depth and, hardness.
Yes.
And based on your experience, you'll say, hey guys, this is not going to work if we treat like this.
Yeah, exactly.
We will recommend to do these changes on the spec. So based on the heater experience, we'll have the desired result.
Precisely.
Right.
Exactly.
So, but you will engineer the recipe.
Yep.
They just will give you the specifications of and the part.
Precisely.
Okay.
Yeah.
Well, yeah. That should be a lot of planning before running one of these gears.
There's planning. There's give and take. There's a lot of discussions. It's not just a question where one day you're sitting there and all of a sudden this truck shows up with a big gear on it. I mean, there's a lot of discussion on one of these things. And there's a lot of negotiation also,
Oh, I bet.
Yeah.
I bet. I mean, guys like me, we're always talking about a lot of volume of parts, right?
Yes.
Hundreds of thousands of parts. In your case, do you deal specifically with one part per, let's say, per quote, per invoice, I will guess?
Yep.
Yeah.
Exactly.
A lot of considerations only to treat one huge part. About logistically, I mean, commercial heat treat is standard commercial heat treat. I mean, because you're very specialized, is meant to be a geographical business model, right? Does this apply also to MedLab? How far away is your farthest customer?
Well, so we have one customer in the Middle East. We actually do a job for a customer who sends us tank turret gears for nitriding. Those are very interesting gears. They manufacture a tank, and it's a combination of a bearing race and a gear that spins the turret around on a tank. We've been doing that job since we acquired the company. Every year we get about 60 of these parts, and That's also a job that's very sensitive to distortion because it's a very flimsy part. It's roughly 96 inches in diameter, outside diameter. Inside diameter is about 94 inches, so it's only 2 inches wide, and it's only about 2 inches high. And we do about 20 at a time. So we've had to develop special fixturing so we can get 20 of these parts in the furnace at one time and make sure that they stay nice and flat and round and they don't distort. And again, it's nitriding, so it's relatively low temperature, so the opportunity for distortion is relatively small,
It's
but
minor.
still, it's like the princess and the pea. If there's a pea on the bottom of the mattress, you can feel it all the way on the top.
Oh,
It
totally.
multiplies. So we've got to be very careful in terms of how we do that.
So we talk about carburizing as well, but you just mentioned nitriding.
Yes.
Which other? Well, I'm pretty sure you do a bunch of oil and quench, standard hardening. Which other processes can you are required for these type of parts? You say nitriding. Of course, it should be a neutral hardening, carburizing. Is there any other process that you do? Well, I will assume stress relieving and normalizing.
So having the ability to thermally process parts under protective atmosphere and do large parts is a very good arsenal of processes to have. We do a lot of stress relieving under specialized atmospheres for customers. We have just started working with a manufacturer of rockets, quite frankly. Now that NASA has started to offload some of their manufacturing to SpaceX and Blue Origin and some of these other companies, it's amazing what these guys are coming up with as far as their requirements are, and it's not unusual for us to be doing things with wet hydrogen at high temperatures, so we're doing some of that for these guys, which I never thought I would be doing, but we are doing. They're quite profitable. The thing to always maintain focus is you don't want to put your furnace in orbit, I guess. But so we do some of that. We do some specialized stress relieving under argon and under atmospheres. Under nitrogen is quite common. We do a lot of work with stainless steels with 17.4 and 15.5 and things of that nature. Interestingly enough, in the late 1990s, we were approached by a manufacturer of they called them intermediate bearings. They were carburizing these bearings. They were basically 3 feet in diameter. And what we could carburize in a week would take them a month to carburize. So they would send us maybe 50 of these bearings. We would carburize them in one load. We would send them back, and they would use their furnaces to quench and temper them. They would press quench them, and we would save them an inordinate amount of time by being able to carburize them, and then they would go ahead and press quench them, and it was really great business for us. We had that business for about 2 years, and it really put us on the map. It made us quite profitable back then. When in all honesty, we were struggling back in when we first acquired the company. We didn't quite know what we had. We knew we had great furnaces. We knew we had great capacity, but we really didn't know how to market it. And that business really launched us in terms of being able to offer the company. And then slowly and surely, we got some of these large gears off the ground, and then we started finding more and more applications. So again, when we acquired the company back then, we had a staff of about 18 people. Today we got about 40, and slowly we got the thing going. We also discovered that having the ability to do and process large parts was great, provided you had them. There were times that despite having all this great capacity, we didn't have that business.
Sure.
So in 2001, I believe it was, we bought a company that heat treated small parts, and they also offered black oxide, and they had pickup and delivery service in the local area, and they had about 10 people on staff. So we took one on one and we made 3, We offered heat treating large parts. We offered nitriding, and then we had the ability to do small parts and black oxide and pickup and delivery.
In the
And
same area, was this in Philadelphia?
sorry, this was in Philadelphia. Yeah,
No,
exactly.
This is the company called John B. Potero Company.
John V. Potero, yeah. It was a
Okay.
little mom and pop company that
Okay.
that dovetailed quite nicely with what we were doing on the large side, and it really made us who we were.
That's very nice, Mark. It's been amazing to have heard your personal story of success, and I feel your passion for heat treating, and what you do is pretty unique worldwide. And I believe it's a great milestone, like you mentioned, that you're doing, space work that you never thought you will be doing. But if there's a person that can do it after looking at all your profile, is you. So you just want to say congratulations for being a great heat treater. Taking MedLab to that big area. I wish you, and I'm sure that you're gonna have a bunch of success, and you are gonna keep doing it. We're gonna have greater and greater story by times. And I always like to ask my guests this very last question, which is not on the heat treat side. It's more on the personal side. You've been in the industry for 50 years. You've been on sales. You've been in process. You have retired on typewriters, books on metals. And right now we have a problem or a situation with the new talent. We people like you are retiring, and we're not filling those positions with enough new engineers that they get passionate as you for a lifetime of heat treating. What will be a personal advice that you will give to this young engineer that is deciding if to go for material science, to apply for that metallurgical engineer at a commercial captive heat treat shop in order to be the next Mark Podobs of the industry in 50 years?
That's a terrific question, and I think the best advice that I could give a young person is to follow your dream and follow your passion. To work hard, to study hard. Don't take no for an answer, and apply yourself, and reach for the stars. I remember as a young engineer working at Pratt & Whitney, 5 o'clock, the horn would go off. They had the factory horn would go off. And I was one of 150 metallurgists, and I would look around, and the horn would go off, and 3/4 of the guys would get up and walk out the door with their lunch pail and go home. And 25% of the guys would sit around, and they were still writing things and doing things and working hard. And I was one of the guys that would get up and leave. And I would say to myself, what are these guys doing, hanging around? Why are they still here? And then slowly, after a couple of times of that happening, I figured it out. And I understood why the guys were still there working hard. And all of a sudden, I became one of those guys. It may sound corny, it may sound funny, but you have to apply yourself. And
so they were applying themselves, the guys
they were applying themselves. They figured out that you work hard, you take hard, people notice who you are, you advance, you do well. And today, these are the guys that are the captain of industries. These are the guys that are in charge. And the guys that got up and left at 5 o'clock when the horn went off to go across the street to the bar and have a good time, they're probably still doing that.
But thank you.
It may sound corny, but
it is not, and coming from you means a lot, because you have gone a long way. So I just would like to thank you again for taking the time. I do feel your passion for heat treating all the way through the Zoom call. So thank you very much, Mark. It's been amazing to meet you, talk about it, and you say reach for the stars, and you're doing work for SpaceX and NASA. You're reaching stars. So hopefully not with a furnace, right? But
Yeah.
but with a gear that we talk about hydrogen. So Mark, it's been great talking to you. And just would like to remind the audience that we're talking to power players like Mark on the industry of heat treating. It's always very educational. And we'll see you again on another episode of the Heat Treat Podcast with another power player of the industry.